Hello. So this time we are talking about connecting a current source, as you can see here, to a capacitor C. And this is a constant current source, and we want to measure or determine a voltage across this capacitor when this current is going to charge this capacitor. So we know that capacitance C is equal to charge upon voltage, where V is the voltage across the capacitor. Therefore, the V can be written as charge upon the capacitance. And we know that charge is the current multiplied by the time, or in other words, I is equal to charge per unit time. So if there is a change in time, we can say there is a change in voltage. Therefore, we write the delta V is equal to I over C multiplied by the change in time delta T. And taking the ratio of delta V over delta T is your I over C. So if you want to calculate a charge If you want to calculate a voltage across the capacitor in a given time, and if you know the value of current and the value of capacitance, you can know in a particular amount of time how much is the voltage across the capacitance. Once you know the voltage across the capacitance, you want to know the charge held by that capacitor. So it will be calculated with this equation. Because you know the capacitance, you now know the voltage in a given amount of time. So let's say you have this constant current source, which is 1 milliampere, and the capacitance is, let's say, 1 microfarad, and we are using this equation, for example, initially to calculate the voltage across the capacitor in a given time. So this would be, I will be 1 milliampere over, let's say, 1 microfarad into 1 second. So in 1 second, as soon as you connect this current source to this capacitor, it will start the process of charging it, and it can be written as 1 into 10 to the power minus 3, and this is 1 into 10 to the power minus 6. So it will become 1 into 10 to the power 6. So it will be like 1 into 10 to the power 3. How much is the voltage? Milliampere into milli micro one. So it goes this one. So it will be like 1000 after 1 second of time, our voltage across the capacitor for a given value of current and the capacitor is about 1000 volts. Okay, and if it is like 1 millisecond, then you can say it is 1 volt. Okay, but for example, if you say time is t equal to 1 millisecond, then it will be 1 millivolt. What about delta V over delta T? So you see the voltage starts and the time T, and we can draw the curve here to understand the behavior about the voltage charging. Usually there is a change in voltage due to change in time. So we start with, let's say, 1 millisecond here. Then you have a 2 millisecond, then you have 3 millisecond, you have 4 millisecond, and this is in the millisecond time. And the voltage will be in the volts. Okay, so at 1 millisecond, we saw the voltage is 1 volt. So here it is 1 volt. At 2 millisecond, okay, so it will be like 2 volt. This will be 2 volt. So it will be like 1, then it is 2 volt, then at 3 millisecond 3 volt, and at 4 millisecond 4 volt. So it would be like a linear relationship between the voltage across the capacitor and the charge and the voltage that is being given. So this is how the behavior of your voltage and time, and this graph is changing, is telling us the capacitance being charged with a constant current source. Okay, so these equations are very important for us to know. uh, there is a one more equation. The voltage across the capacitor VC is given over 1 over C integration of the current time DC, okay, plus constant C. So constant C indicates initial voltage across the capacitor. So if the capacitor is initially fully discharged, then we neglect this C, and then we just integrate the current over the time. So with this also you will get this kind of answer. You can just plug in the value of capacitor, plug in the value of current from 0 to time t, and then integrate, then put the limits and do that. Let us try if we can do it. We can see if we can do it. So let's say voltage across the capacitor and 1 into 10 to the power minus 6, that is the value of capacitance. Then you have 0 to 1 millisecond, and I is 1 milliampere. Did we take the 1 milliampere? Yes. So 1 into 10 to the power minus 3 dt. So VC will be equal to 1 over 1 into 10 to the power minus 6, and you are integrating the current now. So it would be like 1 into 10 to the power minus 3, 0 to t. Okay, that's it. You have the limits now to put in. So it would be like 1 into 10 to the power minus 6, and it would be like 1 into 10 to the power minus 3. So that's your first. When you put value of t, which is 1 millisecond here, it will be 1 into 10 to the power minus 3. Okay, and then you put the 0, then that second term will be 0. So if you solve this, so it would be like 1 into 10 to the power minus 6 divided by 1 into 10 to the power minus 6. It is 1 volt. Very simple. So this is what we just calculated. This was like time t equal to, this is the answer for time t equal to 1 second. But if you have a time t equal to 1 millisecond, you get this one. So this is how we could calculate the voltage across the capacitor when it is fed by a constant current source. So hope you understood the basics of capacitance charging and all the relationship between charge, voltage, and current, and the time, the relationship of the time. So if you like the video, do click the like button, comment on it, and share it with others. And stay tuned for more informative content like this. Till then, wish you